So let us start. So continuity and differentiability. Here, this is straightforward and simple concept. So the continuity and differentiability, what it means is, by name it suggests, so if the function is continuous or not. If the function can be drawn graphically continuously without any breakage, is called a continuous function. Called a continuous function, right? So this is the fundamental principle behind it. That means, suppose if I have given a function y is equal to f of x, let us say y is equal to x square. Now this curve is nothing but the parabola, and this parabola, if you want to draw it on a graph, then this will come in this way. And if you notice, I never lift the chalk piece when I am drawing this entire curve, right? So that's why this is continuous within the range of this x1 to x2, whatever I have specified here, right? So from this x1 value and till this x2 value, this function I could able to draw without lifting the chalk piece, hence it's a continuous function. But analytically, if you want to test it, so the way you do it, at any point of your interest, right? Randomly, if you select any point, there, if I wanted to check if the function is continuous or not, then what I have to do is, let us say at this particular point, if I could able to draw this graph continuously, then it is a continuous function. Now I am going to check the same thing with an analytic manner. That is, if I approach from the left side, then the function value, whatever I am going to get it there. And if I am approach from the right side, then I will check what is the function value there. So that is with the help of the limits. Now in both the cases, if the value is same, then we say that the limit exists for that particular one, and that limit value will be calculated based on the limit calculation from left to right. Got it? And then correspondingly, the function also has to have a certain value there, and that function value is nothing but, let us say if this is a, then the function value is f of a. So if the limit is equal to f of a, then the function is continuous. Function at x equal to a. So this is how we are going to test it. That means the limit value you have to find it out, and the limit value you need to verify whether it is matching the function value there. If it is same, then it is a continuous function. If it is not, then it's a discontinuous function. Got it? Got it or not? Suppose I take one case, that is y is equal to 1 by x. Now if I try to draw the graph of this will be this way. This is how the graph it will be. Now here, if I take x 0 place, that is immediately after the right side of 0, then the function value is almost infinite. Now immediately after the left side, that is on the left side, then the function value is coming out to be minus infinite. Then the left side value and right side value is not matching at x is equal to 0. That means limit doesn't exist. Limit doesn't exist at x is equal to 0. But at rest of the places, if you notice, from minus infinite to 0, so this function I could able to draw without lifting my chalk piece. That means this is a continuous function. And then if I start from 0 and then till the infinite, I could able to draw this graph without lifting my chalk piece. That means this function is continuous between minus infinite to 0 and then 0 to infinite, but without including this 0. That's why this is a open bracket. open bracket says that is not included, closed bracket says that it is included. Now minus infinite to 0, that is very next value after 0, maybe on the left side minus 0.00001 also included, but 0 is not included. On the right side also 0.0001 is included, but 0 is not included. That is very next to 0 is included. Got it? So this is how we are going to test the continuity of any random function you can think of. Here, any questions on this? Any questions on this? Okay, great. So this is about the continuity of the function. Now coming to the differentiability, I hope it is noted down. I can erase it, right? You want me to repeat this? See this. The fundamental concept behind the continuity is, so you wanted to check if I could able to draw this graph continuously without lifting my chalk piece. That is the intention of this. So if the function is continuous, then actually you can say that the function limit exists at that particular point, and you can say that you can even try to check whether the function is differentiable or not. If the function is not continuous, then there is no point in checking for the differentiability itself. So first of all, the limit should exist. If the limit exists, then the function should be continuous, and if the function is continuous, then you can check for the differentiability. This is the order of sequences that you are going to test it for finding out the derivative of any random function. Now here, the continuity, we mean you are able to draw the graph without lifting the chalk piece. So this is the intention of testing this continuity. Now how we are going to test it? That is based on the function value. Take any random function, y is equal to 1 by x. So this is the function I have taken. Now here, if I draw the graph y is equal to 1 by x, this is as if like xy is equal to constant, and this is a rectangular hyperbola, right? So this is rectangular hyperbola. This rectangular hyperbola you will be able to draw from minus infinite to plus infinite, right? So but without including the point of 0. Here if you notice, this is the graph you are going to get it till 0. At 0, it will be almost minus infinite when I am coming from the left side. Now immediately after 0, that is keep x is equal to 0.000001, then obviously the y value will be almost infinite. So this infinite value is coming out on the positive side. Minus infinite value you are getting on the negative side. So at this particular point, there is a sudden jerk or the sudden jump from minus infinite to plus infinite if I travel from minus to plus at 0. Got it or not? Then afterwards, the function value is continuously, it is slowly decreasing and keep on decreasing till infinite, but without any breakages. So this is a continuous function. That means minus infinite to 0, this is a continuous function, but 0 is not included there. And the function is continuous between 0 to infinite, but 0 is not included there. So this is the range of the function for which the function is continuous. But if you wanted to include, that is not possible because the function is discontinuous. That means if I have to draw the graph, I am just lifting the chalk piece and moving from here. Got it or not? How we are going to test it? You will be testing the left limit and the right limit. To test the left limit, so this is limit x tends to 0, 1 by x. This value on the left side, that is 0 minus h. You take it. Limit h tends to 0. Then 1 by 0 minus h. So this is minus 1 by h. And then similarly, on the right side, if you take it, limit x tends to 0, 1 by x can be written for the right limit. This is 0 plus. This can be written as limit h tends to 0, 1 by 0 plus h. This will be 1 by h. As h tends to 0, this will be plus infinite. As h tends to 0, this will be minus infinite. That means left limit is minus infinite and the right limit is plus infinite. These two are not equal. That means the limit doesn't exist there. then the function is definitely discontinuous. If the limit exists, still there is a possibility that there is a discontinuous case here. So for that you will be testing the function value there. Got it or not? So limit value should be equal to the function value. Then you say that the function is continuous at that particular point. Got it? So the continuity will be tested on a range of points. But it is impossible to test the entire range of minus infinite to plus infinite. You will try to identify most probable locations of the discontinuity. There you are going to test it. That will be by intuition. You should be able to identify where all there is a possibility of breakages. Those points you need to identify and then test the continuity there. But usually in the problem statement, 90% of the cases it will be given. But 10% of the cases he may ask to find out your own decisions there. Got it? Vishal? Any questions? Yeah. I hope no other questions. Yeah. And the differentiability. If the function is differentiable or not. Here, the continuity is tested on the function. Right? Continuity is tested on the function. But the differentiability is nothing but a test on the changes of the function. Got it? So the changes of the function, that is limit delta x tends to 0, f of x plus delta x minus f of x divided by delta x. This is how a derivative is defined. This is the definition of dy by dx, the fundamental definition. Now this dy by dx, if you notice, delta x tends to 0. Delta x tends to 0. For the limit to exist, both left limit and right limit should be equal, right? But what if this limit doesn't exist? And there is the question of the existence of the derivative or not at that particular point. If the limit doesn't exist for this, then the function is non-differentiable at that particular point. If the limit exists for this point, then we say that the differentiable function at that particular point, right? So if the limit exists for dy by dx at any point of consideration, then we say the function is differentiable at that point. If the limit doesn't exist, then we say the function is non-differentiable. At that point. So this is the basic definition. For example, I'll give just a practical example. Let us say if we take the relation between wife and husband, then we have expressed the relation between them, y is equal to f of x, where x is wife and y is husband. That means these two people are related by a relation called f or marriage, right? So f is nothing but the marriage. Now on a regular basis, day-to-day activities, so each and everybody, they knows each other's behavior, correct or not? So that means there is a defined function between these two people that you can trace as if like this way. So this is the function which will relate y is equal to f of x. But suddenly one day wife got angry. This is nothing but the change in the behavior of the original attitude of the wife, correct or not? So there is a change that is happening. Now correspondingly automatically there will be a corresponding response even from the husband as well, right? So that means f of x plus delta x, this will be treated as y plus delta y. So this is the change in the husband and this is the change in the wife. So she got anger. So he might be responding maybe with anger or maybe with soft corner, right? So that response is there. Now the continuity is nothing but for a defined value of function. So suppose today, let us say morning 7 o'clock, she prepared the tiffin. And next day also, if she prepares the tiffin exactly in the same manner, the process is continuous. That is expected. But if there is a change that is happening, that means she got anger, then automatically there will be a disturbance in the regular process, right? So that disturbance, is it continuous? What it means for us? Suppose today she got anger and there is a corresponding response for the husband. Next day also she got anger again. For the same amount of anger, is the response exactly same or it is different? So this is what we are talking about, is deviated from the normal process. So that deviation is nothing but the change. For the same change on this day versus for the same change after one day, is it exactly the same or different? That's what is nothing but the differentiability. Got it or not? If the regular process you are going to test it, that is nothing but the continuity. If the changes you are testing it, that is nothing but the differentiability. Got it? Understood or not? So that changes, that's why you are talking about delta x here. Earlier, we are talking about x tending to a there. So there we are talking about only the function value. Here we are talking about, or we are only concerned about the changes of the function. That is the major difference between the differentiation and the continuation, or the function versus calculus. Got it? So this is the basic difference between algebra and calculus. Algebra talks about only a standard function, but the calculus always starts with the changes in the original behavior. So that change, so because every aspect in the society or physics or engineering or everywhere, it always dealt with the changes of the originals. So these changes are dealt with the help of calculus. That's exactly the reason why we have elaborate applications of calculus. Got it? So, but for the entire calculus, the root is started with the limit. The root is started with the limit and is expanded with differentiation. So these are the fundamental principles of calculus. So 99% of the cases we will be able to find out, or actually we are sure that most of the times the functions are continuous or the functions may be differentiable, but we have to be aware one fact that there might be a cases wherein the function may be discontinuous or the function may be non-differentiable also at certain locations. Got it? So this is the basic fact you have to be aware. And in our syllabus, whatever we have is, that is the existence of the derivative and the existence of the continuity. So these are the base rules we need to be testing it. Got it? So the methodology for that what we have followed is finding out the limit, left limit and right limit, and then the function value. If all the three are same, the function is continuous. Then the corresponding changes on the x value on all the times is, if it is same, then we say that the function is differentiable at that particular point, or if not, then it is non-differentiable. That means basically mathematics point of view, what we are doing is the existence of this limit, nothing more than that. So this is just the existence of this limit. If it exists, differentiable, not, then non-differentiable. Clear? Any questions? So this is about the differentiability. So for the existence of the limit, you are going to test the left limit and right limit. That's it. Now, based on this understanding, we'll solve some of the problems. Then afterwards, we will start with the mean value theorems. Note down one problem. Discuss the continuity and differentiability of the function. Discuss the continuity and differentiability of the function continuity and differentiability of the function, f of x is equal to 1 for minus infinite to less than x less than 0, and this is 1 plus sin x for 0 less than x less than pi by 2. 0 less than or equal to x less than, yeah, and this is equal to 2 plus x minus pi by 2 whole square for pi by 2 less than or equal to x less than infinite. So this is the function. Now he asked us to discuss the continuity and differentiability of this particular function. Now actually he didn't ask for any particular point here. So we need to identify the points and then try to test it. Now here, if you notice, this particular function is a constant function. That means if you draw the graph of it from minus infinite to 0, without lifting the axis, you will be able to draw it. That means this is a continuous function till minus infinite, from minus infinite to 0. But exactly at 0, there is a change that is happening. That is, if the function value is 0 plus onwards, that is 1 plus sin x till it is less than pi by 2. But it's not including the pi by 2 here. Here, the function is included in the pi by 2. From pi by 2 till infinite, this function value is 2 plus x minus pi by 2 whole square. This is the function value. Now, there are two possible locations where there might be a possibility of having a discontinuity or the differentiability non-existence. Now, what are those points? So one is at 0, that is correct, and another at pi by 2, exactly, right? So those are the two possible locations where there is a possibility of having the non-continuity or non-differentiability. Now, can you test it, whether the function is differentiable or not, or the continuous or not at 0 and pi by 2? So continuous at Siddharth? In both the cases. Okay, what about differentiability? So non-differentiable at x is equal to 0. I hope everybody got it. What about x is equal to pi by 2? So differentiable at x is equal to pi by 2. Yeah. Sorry. Yeah. So this function is continuous at both the places. At x is equal to 0 and x is equal to pi by 2. So differentiable at x is equal to pi by 2, but not at x equal to 0. So this is the answer. I hope everybody got it. Were you able to solve it, or you want me to solve? Others also? Is it only the differentiable part? Both. Okay, fine. So let me solve this. See this. So for checking the continuity, you will be identifying the limit existence and the function value. Now at x is equal to 0. So at x is equal to 0, now actually what is the function that you have to consider to find out the function value f of 0? What is f of 0? Where there is 0 condition, that is here minus infinite to 0. Yeah, that's exactly the problem. So Anubhav, see this, minus infinite to 0, this is 1, but from 0 including 0, this is 1 plus sin x. That means when you are considering at x is equal to 0, the function value is, you need to substitute 1 plus sin 0. So that is 1 plus sin 0. This value is 1. But you need to consider this function, not this one. 1 plus sin x, you need to consider it. Right? 1 plus sin x, you need to consider it. But you can substitute the value of the 0. Then you are going to get the function value f of 0 is equal to 1. So, because we wanted to test limit x tends to 0, f of x, this is on the left side, and limit x tends to 0 plus f of x, these two should be equal, and the same thing should be equal to the function value also. Then only we say that the function is continuous. That means this is the fundamental condition that we need to test the continuity of any random function. Now here f of x value on 0 minus. So first I will take this part. This is part 1 and this is part 2. This is part 3. And part 3 is already done, and this is 1. We have got it. And the part 1 we can check it. So that is limit x tends to 0 minus. So 0 minus means the function value here itself is 1. Right? Because 0 minus you need to consider this part. So this is a constant function. Then this value is automatically 1. And the right limit, limit x tends to 0 plus f of x. F of x is nothing but 1 plus sin x. Now this can be written as limit h tends to 0. So 0 plus can be replaced with 0 plus h. F of 0 plus h, that is 1 plus sin of 0 plus h. So this value, limit h tends to 0, 1 plus sin h. So this value is again coming out to be 0 because sin 0 is 0. So, sorry, this is 1. Yeah, 1. So if you notice, the function value is 1 and the left limit is 1 and the right limit is also 1. This is 1, this is 1 and this is 1. So all are equal. Hence the function is continuous at x is equal to 0. You got it? Okay. So this is the first part. And similarly, continuity we will test it at x is equal to pi by 2. Now, first I will check the function value at x is equal to pi by 2. Now, at x is equal to pi by 2 use this range because this is less than or equal to. So that means equal to is also included here. So when x is equal to pi by 2, then this value will be pi by 2 minus pi by 2 whole square plus 2. Then this value is 3. So in the part 3 part, we have got the value is 3. And then we'll take the left limit. Limit x tends to pi by 2 minus. So f of x. F of x value pi by 2 minus will be this part. This is 1 plus sin x. Right? So this can be written as limit h tends to 0, 1 plus sin of pi by 2 minus h. So sin of pi by 2 minus h, limit h tends to 0. What is this value? Limit h tends to 0, 1 plus cos h. This value is coming out to be 2. Is this correct? Can somebody confirm? Is it necessary to introduce h? That is up to you. Without introducing also you will be able to solve it. Correct one. Yeah. This is correct. So, but I think so. The function value here when we calculate, right? So x is equal to pi by 2. Pi by 2 minus pi by 2, 0 plus 2 is not 3. This is 2. Yeah. So this is where I got confused. Yeah. So this is 2. And then this function value is coming out to be 2. So is it necessary to introduce h? This is actually, as I told you, this is a more systematic way and very less possibility of making mistakes if you introduce h. Or else you need to approximate the value and try to guess it. That will be a little bit complicated. That's exactly the reason why we have introduced h. Without introducing h also, if you do it, if the answer is correct, you are going to get the marks. No issue in it. Got it? Yeah. Here and then limit x tends to pi by 2 plus. So pi by 2 plus is this function. So this function 2 plus x minus pi by 2 whole square. So this is limit h tends to 0 and 2 plus x can be replaced with pi by 2 plus h minus pi by 2 whole square. So this is pi by 2 and pi by 2 will cancel. 2 plus h square and h is equal to 0. The final value is coming out to be 2. So this value is 2 and this value is 2 and this value is 2. Now the function is continuous at x is equal to pi by 2 also. Got it? Understood? So this is the continuity test. Now the differentiability test is you need to identify the left limit and right limit, both the cases. So left limit and right limit you identify it, then if both are equal the function is differentiable. If not, it is non-differentiable. That is, this value is x. Now the left limit is, so left limit, so limit h tends to 0 minus f of, so at x is equal to 0 we are trying to test it, f of 0 minus h minus f of 0 divided by h minus h. Yeah, got it? This is the differentiability test. Why we are taking this as minus h here? Why we are taking minus h there? If it is left limit, then I can take straight away negative. Yeah. So 0 minus h, exactly, right? So 0 minus h, that is the reason why we have kept 0. So minus h here. Now here the function value is f of 0 is coming out to be 0. We have calculated it already. So sorry, function value. So f of 0 is 1. Then f of minus h. So f of 0 minus h, that is this value is coming out to be 1. So this is 1 minus 1 is equal to 0. And the right limit will be limit h tends to 0 plus. So this is f of 0 plus h minus f of 0 divided by h. Now what is this value? What is this value? So this value is f of 0 minus h. Then 0 minus is negative. This is 1 and f of 0 is again 1 because sin 0 value is 1 and divided by minus h. This value is coming out to be 0. This is the left limit. And the right limit is limit h tends to 0 plus f of 0 plus h minus f of 0 divided by h. Now 0 plus h, that is right side of 0 is this function, that is 1 plus sin x. So 1 plus sin x is nothing but 1 plus sin h. And then f of 0, that is if you substitute 0 here, this will be 1 and then denominator h. So this value is limit h tends to 0 sin h by h and this value is 1. So left limit and right limit are not equal. Got it? Understood? So this is the differentiability check. Exactly in the similar manner, if you do it for this function, that is at x is equal to pi by 2, 0 minus or pi by 2 minus, you will take this function. Pi by 2 plus, you will take this function. Follow the same procedure. You are going to get the same value, which is nothing but the differentiable function. Got it? Note down one more. Consider the function Consider the function f of x is equal to x minus step x, where x is a positive variable. Where x is a positive variable. And step x denotes the integral part of x. Integral part of x. Step x denotes the integral part of x. And show that it is discontinuous. It is discontinuous for all integral values of x. For all integral values of x, and continuous for all other values. Can you solve this? The function is x minus step x. This is also called as set x. Set x is equal to x minus step x. Now actually the function is nothing but the set x. This is f of x he has given. Now he asked us to prove that for integral values of x, the function is discontinuous and rest of the places it is continuous. I will give the graphical approach. From that actually you will be able to make out this is, so this is a step x graph. That is, if you take 1, 2, 3, 4. So 4 intervals I have taken. Now x minus step x. Suppose let us say x is equal to 0.5. Then 0.5 minus step of 0.5. Step of 0.5 will be 0 because that is the integral part of it, that is 0. So 0.5 minus 0 is nothing but 0.5. So whatever may be the possible value, I take it from 0 to 1. So this is always as it is coming, y is equal to x. That means, so till 1 if I draw it, this is the kind of graph I am going to get it. Now after 1, what happens is, again, so I take 1.5, then 1.5 minus step of 1.5. This is 1.5 minus 1. This is again 0.5. So this is as if like we have got for 0.5. So the same value whatever we got at 0.5, you are going to get the same value at 1.5, 2.5 or 3.5, whatever it may be. Similarly, whatever the value you got it at 0.1, same value you are going to get at 1.1, 2.1, 3.1, 4.1 like that. That means the same graph is getting repeated. So this is the kind of graph, this is the kind of graph you are going to get it. This is a sawtooth wave. So this is the graph. Now if you notice this graph, what is happening is at 1 minus the function value is different, and 1 plus the function value suddenly drops to 0. That means this is discontinuous at this point, this point, this point and all these points. So this is discontinuous. At rest of the places it is continuous. So this point, this point, this point and this point continuous. And this is what he asks us to prove mathematically. Got it? So for that actually you need to define the function first. So given a function value, now we will divide for an integral value. The function value is exactly at n and exactly at n plus 1 and n minus 1. So if you randomly take an integral value n, that is from n minus 1 to n, what is happening? And exactly at n, what is happening? At n to n plus 1, what is happening? So that means if you randomly consider this point, exactly at 2 what is happening, before 2 what is the function, after 2 what is the function. So these are the 3 cases actually we should be identifying it. Now here, what is the function value? This is x minus n minus 1 is the function value at this point, because that is the integral part of it. That is x minus step of x. So step of x will be n minus 1. Now exactly at x is equal to n, this value will be straight away equal to n. Got it or not? So what is step of 1? This will be 1 only. Step of 2, this will be 2 only. Got it? Now n to n plus 1, this will be x minus n, definitely, right? So that is n to n plus 1, whichever is the lower part that it is going to take it. So this is the lower part, this is the lower part. So x minus n minus 1, x minus n, but exactly at integral part, this is exactly the same value. So this is the original function that was defined for the ranges specified here. So if you are able to make out this particular function, you will be able to identify the continuity and discontinuity at every point in this equation. Got it? Understood? Tricky is to identify this function, but graphically you can straight away say that the function is discontinuous at all the integer values. Clear? Any questions on this? At x is equal to 0, right? So here actually he said that it is above always a positive number. So we don't know the information below this one. That is, before that value we don't know the information. Then without knowing the information, you will not be able to identify whether the function is continuous or not, because the left limit we don't know. Got it? So from 0 he said without including 0. Understood, Prithvi? So the problem statement itself actually he stated clearly x is a positive. Any other questions? As I told you, here actually we don't have sufficient information to find out the limit existence or the continuity check at x is equal to 0. That's why we are trying to identify the existence of the continuity from 0 without including 0. Got it or not? So 0 is not a positive, is not a negative also. That's why here actually if you wanted to test it, sufficient information has to be provided. But in this particular problem statement, that information is not given. That's why the scope of the problem is 0 plus. Clear? The function for the negative also, right? So, okay, first you note down this, then actually the same function I will derive even for the negative also. So if x is negative, upper limit is going to be taken. Yeah. So I think you people need to understand what is step x, set x and all. So maybe that is the reason you are getting confused. So step x is defined as the integral part. Now the graph of this step x is, so many people get confused that what is step of minus 1.5? What is step of minus 1.5? It will be minus 2. Yeah. So it will be minus 2, not minus 1. So if you draw the graph of the step x, it will be 1, 2, 3, 4, and this is -1, -2, and -3. Then the graph starts with -1, but this is 0, and this is 1, and this is 2, and this is 3. But here it starts with -1, go to -2, and then go to -3, like this. This is how the graph will be. On the negative side, it will be 1 extra. Got it? Yeah, greatest integer function, exactly. So that is the integral part of the function. So when we see it, step x, right, you always look for the left side of it. That is, left side integer, you can straight away say, left side integer. Suppose if I randomly pick a value from here, that is, let us say, I say 0.5. So left side to 0.5, there is 0. So this is the integral part of it. Suppose if I take the value here 1.5, the left side to that one is +1. Exactly in the similar manner here, I take -1.5, left to that is -2. So you always need to look for the left side value. Got it? Now, based on this understanding, what is step x plus step of -x? -1 is correct, but it is partial. So this value is -1 if x is non-integral. But if it is integral, this value is 0 if integer. So step of +1, so step of 5 plus step of -5. This value will be +5, this value will be -5. The sum is 0. But here, if I take 5.5 and step off and -5.5, step off, this will be 5, but this will be -6. This will be -1. This is the difference. Yeah, -1 or 0. So whatever may be the x value, if it is integral, it will be 0. If it is non-integral, it will be -1 always. And then set x is defined as the fractional part of it. Use the fractional part. So this is the fractional part. The fractional part is always written as step x is equal to, set x is equal to x minus step x. Got it? Now, so on the positive side, actually we have defined the function. So this is coming out to be a function like this. Now on the negative side, actually we'll see. So let us say I take -1.5, then -1.5 minus step of -1.5. So this value will be -1.5 plus 2. This is plus 0.5. Now this itself is sufficient enough to guess the curve of it. This is exactly the same curve. Got it? Understood or not? Suppose if I take this value here, let us say this is 0.1, I take it. So minus 1.1, if I take it, this will be minus of 1.1. So step of minus 1.1 plus step of minus 1.1 is minus 2. So minus of minus 2 will be plus 2. 2 minus 1.1 is 0.9. So here actually you are going to get 0.9 if it is 1.1. That means you are getting, keep on reducing the value if you go from the left, so right to left. So the same curve is getting repeated even on the left side. Got it? Understood? Yeah. So this is about the special functions. Do you have any questions on this? Any questions? Okay, great. So with this, I would like to stop the class for today, and tomorrow we are going to take up the mean value theorems. Yeah. So I am going to give the topic test. Sorry, actually I didn't give yesterday. So this topic test for entirely limits, continuity, differentiability, I am going to give it tomorrow. So I'll post in the group. I hope everybody joined the Telegram group. So if anybody is not joined, you send me a message to me. I will add to that group. So good night. Yeah, thank you.